How's it going, everyone? My name is Paul Leiser. I'm a principal technical specialist. Work across many federal organizations. And today we're talking about Azure OpenAI use cases and demos. And these are going to be use cases that have been provided by many federal organizations, though they have been generalized to not call out any specific organization. All right, it's always important to talk through what we use and do not use when it comes to Azure OpenAI, and whatever you send to Azure OpenAI is yours. We do not save it, we do not record it, we don't share it with OpenAI to improve the models, we don't use it to improve our models. If you do any fine tuning, that's exclusively yours. If you want to know what a user submitted to Azure OpenAI and its response 2-3 weeks from now, we cannot get that information for you. It's up to you as an organization to save that information if you want to retain it and analyze it and see what's going on. All right, so we're going to look at the use cases here, but before we jump into the use cases, it's important to understand what tokens are, because this is how the models function. This is how they read what you submit and generate responses. And tokens are just the fundamental unit. They're a way to, develop, the cost for the energy used to generate the tokens, to read your information and to generate the responses. And here's an example of it. We're going to use English here. It works with any language though, but most words are a single token. Some words you can see they're like generative are 2 tokens, grammar are 1 token. You can say 150 characters is 25 tokens, and costs are related to by the 1,000 tokens, pennies per thousands of tokens. So dollars per millions. All right, so these are the use cases. There are some more outside of this though. From a demo perspective, I want to show what Azure AI Studio looks like, but we're going to get through these first. So the first one here is document generation. And what that is using your information. So we're going to use RAG, retrieval augmented generation. That's where you have a database of information or repository of information, and you want that to be used as the knowledge source when prompting the model. So we have the file search, we have code interpreter here. We will not use that, but we have the file search. All these videos I've recorded, I've tried to pare them down so they're specific to the task as possible. So some things are sped up, but they're not dramatically sped up. All right, so here we're going to generate a statement of work. We said, hey, we have a statement of work. I want you to create a template from it. And then once you have that template, then you can use your data to populate that information. And ideally, you don't want to populate it at once. You don't want to say, hey, populate everything with what with the information you have. You want to go section by section. You're going to get the most articulate response that way. So I'm just showing the vector store. Again, this is where the information is residing, and I'm using the assistance protocol right now, or API. I want to go through a lot of different scenarios and interacting with Azure OpenAI. We'll use assistants, we'll use chat, we'll use web apps, we can use Jupyter Notebooks. We're going to use a lot of tools to interact with Azure OpenAI. All right, so here's a really good one, transforming hardware specs. So a lot of federal organizations use hardware that you interact with them over serial bus or any of those kinds of buses, or even SCADA protocols or TCP protocols. But the vendor generates a document on how to interact with it. And it's almost like a coding language, a programming language in and of itself, instead of commands, how to use it. And these are really relevant when it comes to functional testing. It can be a lot of work though to read through these PDFs and generate a functional test for that one specific hardware. And imagine how many pieces of hardware go into an actual system. So here we're going to go through, we're going to scroll down and find the section that talks through the actual commands. You can see these are the commands there. And this entire PDF has been added to our repository, our index, to be analyzed, so we can then use it to generate our functional testing. And these are the actual commands, the parameters of that. And all the things we're going to show today are not so much chat-based. This isn't necessarily needs to be a conversation with you and the model. A lot of these are almost pipelines, and it's great to use chat-based service because it's really straightforward to use. You use your RAG and you have a chat. You can iterate through things very quickly. It's almost like a minimum viable product, an MVP. You work through it, you build your pipeline, the idea of it, the concept of it, and then you take it and add it to something that's actually a pipeline, maybe Jupyter Notebooks or prompt flow, or you build your own application that executes them in serial or parallel or whatnot. But start with chat. And I think it's really important to highlight this is beyond chat. This is beyond just finding insights in your documentation. It's how can I use my documentation to improve my work and tasks more efficiently. So the next step here, we generated the list of commands out of that PDF. That's the vector database we're using. And then we're saying, hey, create a JSON of that. And there we go. Now we have a JSON of that information that was in that PDF, but now in a JSON format. Once you have it out of there and into a file like JSON that's structured, now the possibilities are limitless. And we're saying, now next we're going to do, let's create a Python script to actually execute this command. And there we go. Now we have Python that connects over the serial bus to execute that command. Now we're 80% of the way to our functional test. Now you can share this out. What used to take 70, 80 hours can be done, in 3 or 4 hours. Really good way to speed up functional testing, remove that monotony of all that, of the work of just kind of transcribing. So you can be the best version of yourself while you're doing these tasks. You can actually use the skills that you have instead of just transcribing. All right, so another thing we're going to look at here is code porting. This is, we've shown code development, create something from scratch, but I think it's important to understand that you can use this to upgrade your code. Moving between Python 2 to Python 3, there are things that are different, the way they've been executed between 2 and 3, so it may inhibit the organization from a risk perspective from moving that as quickly as you'd like to, and migrating away from the security vulnerabilities. You probably maybe put something else in place to help mitigate that, or you've taken a poem or something like that. Here's a way that you can use Azure OpenAI to speed up that work, get off those poems, and get on the modern version of that language. So we're using a to-do app. We're just saying, hey, upgrade this from 2 to 3, and tell me why and what you changed. You can see at the end there. These are the things that were different and how we are supporting them in the Python 3 version. All right, so I was going to look at code modernization. This is going to be very obvious. This is moving from Fortran to C#. I doubt that happens that often, but I want it to be very obvious as to what is happening here. So we have a Fortran app as a to-do app, and we want to update that to C#. This could be anything, though. It could be Oracle database store procedures, and you want to upgrade them to SQL store procedures. You may have an old version of SAS running on a mainframe that's running processes and business logic that the latest version of SAS 5 doesn't support, and you want to upgrade them. Think about any kind of language. It might be Visual Basic. You have a lot of stuff in the organization running in Visual Basic. You want to get off that, move it to Python or C# or C++ or anything like that. Maybe even Rust. So here you go, it's moving, it's developed the application. Is this perfect? It's going to be 80, 90% of the way there. Think of this coding support as another, intern or level 1 engineer that's coming online as part of the team, even another engineer that's of your same skill set. When you guys are working on and submitting code to your repository, you have things that analyze it and review it, as well as putting other eyes on it. You would never just trust this implicitly. You would review it, use it. It's going to not remove you as a qualified technical engineer, coder from the process. What it's doing is helping speed up your ability to get work done, because I'm sure there's a lot of coding to be performed. And it also means you don't have to necessarily scale out the number of people, and not in a bad way. The more people that are working on a single project, the more difficult it is sometimes to coordinate all that work. But if you can speed yourself up to be 75% more efficient working on that, you can accomplish it quicker, maybe with less personnel, they can work tighter and get that done quicker. All right, so this one's a really cool one, hardware logging and error analysis. This is where, again, we're using the assistants now, back to this, and we're submitting the logs in the chat. Think about this, what happening though would be piped into, another way, be ingesting it through an event hub or something like that. And what we're gonna do is use RAG and the logs and troubleshooting guides and SOPs that we have to help analyze any errors and provide action. These are not actions that the model just came up with on the fly. It's using the organization's SOPs, troubleshootings, FAQs to generate actions. This is a way to help speed up, again, workflow. Maybe you have a level 1 engineer after hours instead of having the subject matter expert. It's a way to, democratize access. Also increase that level 1 engineer's understanding of what's going on in the organization, giving them better support in growing their knowledge and getting to the root cause of what's going on quicker. All right, so now I'm going to put some logs in here that definitely have errors. They're going to go through, they're going to show the error and an action. And again, this is not just developed by the model. This is using RAG, the organization's SOPs and FAQs to develop those actions. So imagine this on the NOC floor or SOC or anywhere else to improve and speed up remediation. And in that same vein, we also have predictive maintenance. So predictive maintenance is kind of taking it one step further. Types of hardware. This is a refrigerator. And in this case, we've noticed this refrigerator has a electronic board that monitors the amperage on that refrigerator. And, if the delta on the amperage exceeds 0.75 over the last 10 reviews or, collections, then it's likely that this hardware becomes non-functional within 10 weeks. So we know we need to order the hardware today because it can take 6 to 8 weeks if we don't have a spare on hand to even get it. But then now that we know we have it coming in, we can schedule that downtime. It's a lot better user experience, a lot better experience for the personnel that are managing the system, instead of it being this wildcard thing that's happening where it breaks because you didn't see it coming. And now it's a Saturday night and your evening's been negatively impacted. So here we go. It's going to go through. It's using RAG to analyze this information, to collect the data and say, all right, now we need to get the delta here. We're going to showing everything, so you can trust the work, the standard deviation there, and it's saying, all right, standard deviation exceeds our threshold. Let's order the part. You can use this for anything. This is hardware-based, but it could work just as well for anything software-based. If you have typically seen issues in your Active Directory that have then led up to some event, this can be applied that same way. All right, so now I'm going to look at just interacting with OpenAI directly. This here is with Jupyter Notebooks. A lot of data scientists use Jupyter Notebooks to execute, their Python, generate models, figures, and everything like that. We have a capability within the ML Studio for running Jupyter Notebooks. You can create them here, export them. You can import ones you've created on-prem, and then to work with Azure OpenAI. So each one of these boxes are kind of like a step, and you just execute them. I'm not going to get into this too long. These keys are no longer valid, so don't concern yourself there. And here we go. We get the output, and now we are working with Azure OpenAI. Again, this is the ML Studio. It's a really fantastic place to work with AI, both AI Studio and ML Studio. They have a lot of similarities, but there are parts that do not overlap, and these are one of them. All right, so Postman. So this is interacting with the APIs directly. And I think what's really interesting about this one is all of this is on private endpoints. The virtual machine you see that's running this is on the virtual network. It's connecting to Azure OpenAI privately, and this is actually running in Azure Government. But this same technique is applicable to commercial. This is Azure OpenAI on private endpoints. It's actually going to be doing RAG with Azure AI Search. Azure AI Search is also on private endpoints. Everything here is on private endpoints, so you cannot interact with it publicly at all. And what we're going to do is we're going to search through our RAG and tell us what NIST 853 is. There's a lot, there's a lot here in the data source that, just kind of going through the structure for the body here that you send when you do your post. Here's connecting it to the Azure AI Search vector database, the keys that you need, and then here is the output. So you can see at the bottom here, here's the content that it generated, and then here's the citations. So again, it's not just generating content, it's including the citations in the output response so your application can then associate them. So you understand what did it use to come to this answer. All right, so we talked about RAG and stuff like that. A lot of that is around grounding. Retrieval augmented generation is around grounding. There's two components to that, really, embeddings and chunking. Of course, you need the database to store this stuff, but I think it's really important to understand what are embeddings. Embeddings are just the numerical representation of your data. It's also called a vector. And a vector is just a set of attributes that's used to numerically represent a piece of information. And then once you have that numerical representation of the data, now you can do really great things to find two pieces of information. How are they related or not? Otherwise you use semantics, and semantics don't work necessarily across a huge volume, a lot of sentences and stuff like that. All right, so what does that look like? I'm just gonna go through a smaller example here. The ADA models for Azure OpenAI use 1,536 attributes to numerically represent the information. We're gonna show it with 4 today. And when I say attributes, this is kind of what it means. If we were to just, kind of align these attributes with different ways you would describe a cat. And then you can put other, terms through it. Kitten, dog, house. And now you're going to see a relationship here, and where are they more closely aligned versus not. And then you can reduce that down to, kind of 2 attributes, and to find this, closer relationship here. And this is where, if you were to think this, if you were to add 1,536 attributes, it'd be this really multi-dimensional relationship. We're using trigonometry and stuff like that to really find the relationships. All right, the other part here is chunking, and this is when you just have a document and you want to make it into smaller, get it into smaller parts, separate it into smaller components so you have more contextually relevant information. If you have a 100-page document and you do not take it apart, whenever you ask questions, when you search, you're going to get all 100 pages, even if the information you want is only in paragraph 2 on page 60. And all that extra information is going to dilute the response that the model is going to generate. So chunking helps you save cost. It helps you get more relevant information, and just gives you a better experience and a faster experience when it comes to searching. And here's taking that same kind of information and generating an embedding of it. Embeddings go from -1 to +1. All right, so this is AI search. This is our vector database. This is where, we've used a lot of the techniques and technology we've learned with Bing, plus a vector database. So it has semantic search, it has keyword search, has vector search, it does semantic re-ranker to, whatever you search out of it to reorder it. So you get the best relevant information that you send along to Azure OpenAI to be analyzed. All right, so we have an accelerator here called Information Assistant. This is a tool that internally was developed at Microsoft. It's all open source, allows you to do RAG and really highlight how it's used, how things are pulled apart, and dig into it. It's an accelerator, so you can use it as for your organization, but it's really built as a training tool. And this is what Information Assistant looks like. This gets deployed out. It's relatively straightforward to deploy. It has 3 areas: work only, that's against your information; work in web, so now you can actually search the internet; and then generative. Generative is asking the model specifically, interacting with the model itself and not any of your data or the web's data. You get to upload your files. This is how you manage them. You have folders. These are the file types that it supports. You have folders and tags to help improve searching. You can see as you upload files, their status on being ready or not. All right, so the first thing we're going to look at here is we're going to ask to summarize that article, that document. And there it goes. It summarizes it, and it gives the citations. And these citations actually open up the document in the PDF where it pulled it, and it has these other areas for thought process. Thought process is the system prompt and all the information that it retrieved to help generate the response that you see. Documents, all this kind of stuff. It's really a way to help everyone understand how this is happening. All right, and then when it comes to, when you work with your information, it doesn't work, if it doesn't have that data, then it's going to say, I don't know that information. Even though the model itself has that in its repository of information, it is not using that because we're using RAG. We're saying, hey, if you do not get this information, then do not respond with. Another here, just a quick look at the website. So we're going to search the web. All right, where can I get this? Again, it's giving citations. And then interact with the model. And I think this can be an often overlooked part of the chat side. You can use the chat experiences like you're having a conversation with somebody else. It's not just about finding contextual information in, your data or generating an email. If you have a problem, this is a word problem. That's essentially an algebraic problem where you have a total budget and you have projects that have certain values, and you want to get as many of these projects done as possible. That may be something, you could have a conversation with yourself, and you work through that. But think about Enterprise Assistant or Azure OpenAI as a way to kind of speed that work up. And when you go through that, it's going to, go through all the algebra, so you trust, what that work is. All right, so we're going to jump into AI Studio. This will be a live demo. It has over 1,700 models, a way to fine tune, do benchmarking, create prompt flows, that's those pipelines, and it has capability for safety. So here's the studio. The model catalog, there's over 1,700 models here. I think it's 1,795 from OpenAI to Meta to our small language models to a lot from Hugging Face. Everything's in here. There's some really cool ones in here too, like TimeGen. And TimeGen is a time series based model. So this isn't for chatting or anything like that. This is just to analyze time-based information, time series data for forecasting and anomaly detection. Really powerful stuff. If you have any kind of data that's coming in that's time sensitive, time series, it's going to be great at finding anomalies and looking towards the future. It's great for troubleshooting. Model benchmark, allows you to analyze all the models together for accuracy and stuff like that, whatever it is you're looking for. Coherence. Prompt catalog if you need some ideas on prompting. AI services, these are just other capabilities that are coming in here. We're going to look at these pretty quick. Chat, this is from the Azure OpenAI Studio. So now this is in AI Studio itself, and allows you also to deploy what you develop here as a web app. Assistance, we looked at that earlier. Real-time audio analysis, image generation, completions. This is kind of pipeline work where you're not chatting back and forth, and then speech for transcription. Code, this allows you to connect it in with VS Code if that's your developer's doing. And then prompt flow here. Prompt flow is really cool. Recall earlier we had Jupyter Notebooks and had those different blocks. These blocks are kind of like that. These are functions written in Python that you can do input-output on, analyze, and allows you to build those pipelines. And then when you deploy it, you have an API front end. So you can call that API over and over again as part of your AI application or your just pipeline. You may not need a front end to this. You just want the API, you want to send a PDF to it and summarize it over again. That's what prompt flow is for. And you didn't need a developing team. The data scientist can create this. Evaluation allows you to evaluate your AI application for groundedness. So you are doing RAG. You understand how well am I doing RAG. These evaluations are going to help with that. And then fine tuning, if there is a situation that RAG doesn't really, isn't fitting the bill, fine tuning's there, but this is atypical. If you have any questions on this, reach out to your Microsoft team. And then there's some areas down here for your indexing. So this does your AI search index. These failed. These were intentional at the time. Deployments, these are your models. And then content filters. This allows you to create your content filter. This is your governance for your app AI services. All right. And that calls it for today. That is, walking through all the demos. I know it's pretty quick. If you have any questions, please reach out to me. You can email me. You can find me on LinkedIn. I'd be happy to talk through this. Thank you very much.